Thanks everyone for joining. My name is Hanna, and I'm data and AI lead at Teccle Group. So I work mostly with Microsoft implementations with Microsoft Fabric. And now today I want to explore how Fabric and Neo4j can actually work together to see what VectorRAG and GraphRAG do in comparison, all within Microsoft Fabric. So we only have 15 minutes, so we have to speed up a little. So welcome everyone. Have you worked with GraphRAG or RAG in general before, just to know more or less? Yes? Okay. Nice. So today I brought a use case with me, a demo use case from a pharma supply chain company. And yeah, more specifically, hospitals that are ordering different kinds of medication. And this is a very high-risk environment where we have to answer mostly complex questions as well that doesn't answer themselves by just writing a single query somewhere. Mostly you need multiple hops and multiple relationships to answer questions. So this is what we want to explore today. This is the use case that I brought. We have different types of entities. We have suppliers that produce the medication. We have batches of products, and those batches have different quality features. So we have either quality passed, failed, or on hold. We have warehouses that are storing the batches. We have those warehouses in different locations and regions. And then, of course, we also have orders. So we have requests that hospitals send to the different suppliers for their products. And those requests are either delayed, shipped, or pending. So those are the orders. And the relationship that we have here is that we have orders. The orders are containing batches. And the batches, they are manufactured, of course, by different suppliers. And the batches are stored in different warehouses. So in general, how RAG works, I think most of us know. So I can be quick here. So we have queries, of course, that we send. Then we have embeddings. So yeah, text translated into readable numbers, where then for when you use vector search, for example, you just see what is the cosine similarity between those chunks that you produced. And then you send this to the LLM. The LLM doesn't have any background about the relationships between the data. It's just for answering basically your question. And then you get your answer. And this works quite well in a lot of scenarios. But when it comes to more complex questions, of course, VectorRAG tends to fail those questions because it can only see how similar text chunks are, but it doesn't have the context of the relationship between your data. And if you have quite complex scenarios, for example, with hospitals, where you have different suppliers, different orders and hospitals and warehouses, data coming from all different kinds of sources as well, then vector search tends to fail because it doesn't have the knowledge of the relationships between the data, and it can also not project any multi-hops that you might have in questions. But then we're lucky because we have property graphs. And this is an example of the relationships that we have in my case, or in our case, in the demo pharma scenario. So here we have nodes. So the circles, there are nodes. And those nodes are connected. And you see here the relationships. You can see that the batches with their batch ID and the quality status. They are stored in the warehouses. You can see that the batches are also connected to suppliers. So the batches are manufactured by suppliers with different IDs, with different risks. But then you can also see that the orders also contain different batches because different hospitals are ordering different products. So all of that is relevant if we want to ask complex business questions. And the question that we want to answer today, my demo question, is which high priority orders are delayed because their batch failed quality checks and was made by a high-risk supplier, and where is that batch stored? So this is a kind of question that would be especially in the environment of hospitals where everything needs to be on time and planned accordingly. That's a high-risk question that we want to ask. And we see we have to do multiple hops to actually achieve the question. So we need information about the order. We need information about the batch. We need to see where this batch is manufactured, by which supplier, and in which warehouse it will sit. And that's the point where simple vector RAG would fail because it wouldn't know the relationships between all the different data points that we have here. So in the demo that we will see in a couple of minutes, we have 4 suppliers, 4 warehouses, 6 batches, and 7 orders, just to demo the scenario. And the architecture that we will have a look at looks something like this. So at the beginning, I said I'm mainly working with Microsoft Fabric. And this is also why I wanted to show today that with Fabric and Neo4j together, we can solve this kind of business problem. We have all data stored in OneLake, in Delta tables. We have Fabric notebooks, where we have all our code, so where we run the code, where we connect to our instance in the Neo4j database. We have our data that is projected then from OneLake into the Neo4j database, which I will also show. We have the different nodes and relationships there that we can see. And then we have GraphRAG to answer our business question. And with that, we have a couple of minutes left. I want to jump to the demo. Let me just switch my screens. Nice. Okay, so here we are in the Microsoft Fabric workspace that I created. And within that workspace, I've already stored the data in OneLake. And I have my notebook here where I can write Python code. Here you see that it's connected to my lakehouse in that case, where I stored the data. And then I can just simply start with setting up my configuration to connect to the Neo4j database. I stored everything in keychain, and then I'm ready to connect. Here I just generated the demo data. We will skip that. But then we can start projecting the data into Neo4j database. That's what we do here. So this is just the connection to the database, but here, this is where it gets interesting, because here we can see how we set up the relationships so that in the Neo4j database, we then see the different relationships between the data. So if we look at this one here, batches that are stored in different warehouses and manufactured by different suppliers. We have here this merge statement, which shows that we want to build the node of a batch. If it's already there, then we will skip the creation of the new node. And then here with the set, we can set different properties for this node. So for example, here for the batch, we have different products, we have the quality status, we have the description, and so on. And this is how you basically set up all the relationships within Fabric. And then, if you go on, we can ask our question. Well, actually, let's just have a look at what it looks like in Neo4j, if it works. I loaded it before. Now it seems to lose the connection. Okay, I think I got it. One more second. Yes. So this is how the interface looks like in our Neo4j database, where we projected from OneLake in Fabric our data and our relationships into the graph database. So here, if we zoom in, we can see that we have different products. They are stored in different warehouses, and we have orders containing different products. And then we also have the suppliers that are also related to our batches. So this is, it's quite simple because it's a demo scenario, but this is how it would look like. And if we go back to our question, so we want to know which high priority orders are delayed because their batch failed quality checks and they were manufactured by high-risk suppliers, and we want to know where the batch is stored. So if we would answer that with simple vector RAG, we would get this question which does not answer our, get this answer, which would not answer our question. But then, I need to speed up a little bit. If we go to GraphRAG, and I tried to have our question here answered with our model that we built, the different relationships that we set up, we get a pretty good answer, actually. And we see that those are the 3 high priority orders that are delayed because of the quality checks failed, and they are manufactured by high-risk suppliers. And we also see they are all stored in the Hamburg warehouse. I also run a Cypher query to check if the answer is actually correct. And we can see it is. Those are the 3 batches that we wanted, all stored in the Hamburg warehouse. Okay, now to quickly end our talk. I have 1 minute left. Well, so what are some exemplary use cases that you could build with that? Because of course, GraphRAG is not always the solution to every problem, but it adds quite some value in a lot of use cases. So for example, when you look at financial services, if you look at IT operations or e-commerce, I think almost every industry could benefit from this. And with data becoming even more complex, with more necessities for relationships and basically also projecting those relationships in a way that your business can benefit from it. I think you can do quite some nice stuff with it. Well, I hope that gave you a good overview of what is possible. If there are any more questions, feel free to reach out. I will be here today. Also for some more minutes at the Neo4j booth, we can have a talk, and feel also free to connect on LinkedIn. Thanks for joining.